So we had exercise number 2, like a question. I just asked you for a mean that is called as mu, and that's n multiplied by p. And assuming that they gave you both n and p, then you just need to multiply 250 by 0.45, right? So when you going to multiply these two numbers, well, I guess you need to get the calculator, and I will go for favorite scientific calculator. So the Desmos, right? And go ahead and put the numbers in. So I multiply 250 by 0.45 and get something for the answer like 112.5. So that's what we expect to get when we have the number of elements 250. So you repeat your experiment 250 times, and 45% will come out something that you need. So 0.45 of 250 is something like 112.5. So this procedure is actually utilized very widely, and example could be playing a game in casino. Say if you decide to play roulette, then question is in exercise number 7, if you decided to play it 100 times, so number of times n is equal to 100, and the chances to win, we call it as a p, probability to win is 1 chance out of 38 to win. So right away I can say that the complement probability not to win but to lose out of 38, you're going to have remaining 37 chances, right? The complement. So 1 is for winning, the remaining choices are for not winning, so I guess losing. So that way we got a 37 because 1 is gone for winning, so remaining 37 out of 38 for losing. And in the part A, they want you to find the expected value of winning, which is NP, as well as a standard deviation, which is a square root extracted from n times p times q. So let us times 100 by p, which is 1 over 38. And analogously, for the standard deviation, I multiply 1 over 100 by fraction, actually 100 by 1 over 38, and then by 37 over 38, right? So when I multiply these numbers, I should get part A answers. So let's see what this will be. Again, I'm going to my favorite calculator for that. So try to put this in your calculator and get this answers. So for the first one, we got 2.6 and etc. 3 ... something like that. And then the second part, I'm gonna get 100 and times this by, again, that fraction 1 divided by 38, and then again times. Make sure that you enter these carefully without a hurry, and that will give you the answer for a standard deviation. So that's about 1 1.6, something like that. So, do you have a big chance to win if you play the game 100 times? Well, looks like 2 or maybe 3 times you will win, right? So if my average or expected value, because we always expect the average to win, is 2.6, and then standard deviation, so it's spread to the left 1.6, and then to the right as well by 1.6. So let me add and subtract this number. So this be something like 4.2, something like that. And when I subtract it, be 1.03, something like that. So what do I expect to actually happen when I play this particular game? Well, it looks like I could get either 1 winning or 2 winnings, or possibly 3 winnings, maybe 4. When I say maybe 5, well, maybe 5, but not too many times is what I expect to actually win this game. And probably this gives us pretty low chance. And that's what they're discussing in the part B, that says, is it unusual to win only once out of 100 times? And the answer is not really. It's possible to win once. It's within pretty much the ballpark. We may get lucky and win 4 or even 5, but probably no more than that. And that's why they say if you play this a lot, then you're not going to win much. So maybe if you play it once or twice, but if you start playing it more often, then people don't get to win. And well, I guess that's not the best way to try to make some money playing this game, and probably you can get some funds some other ways. So anyways, in chapter 4, we're looking at 2 sections only, 4.3 and 4.4. So we just done with 4.4. And then we should move on to the next chapter, to chapter 5. There is a section 4.5, the Poisson distribution, that we don't consider in this class. So we just need to start to talk about normal distribution. And that's actually what the statistics is pretty much all about, because on our planet, everything is going to be distributed normally. So the shape is something like that. The people call it as a bell-shaped curve with a mean, that average number mean is in the center of this normal curve. And since it is a distribution, then the area under this curve is equal to 1. That's the reason why we can call this as a distribution, so that area under the curve will be 1. So they're working with these distributions, and turns out section 5.2, where the story starts to work with so-called standard normal distribution. And that's the one that we're going to be dealing with today. We're going to get used to this standard normal distribution that has a very important property that its mean is equal to 0. Technically, the mean can be anything, but if mean is equal to 0, then the distribution has a name, standard normal, and we call, instead of x-axis, z-axis, to just make sure that we are talking about that special kind of distribution, which is very important for application, because we have a way to find various probabilities for it. They actually have the way to find the areas when you are looking at the picture here of the standard normal distribution. I know it is standard normal because 0 is my mean. In fact, they actually tell us this in here, and they want to find the area from z, which is 1.58, all the way to the left. They highlighted this area just like that. So first of all, area is the same as probability. We used to describe probability as big letter P, and I can describe in the parentheses that z is less than 1.58, just like that. So I can try to find this probability using special tables. So what I will do now is go to Google and find Triola tables. You can see Triola tables for this particular normal distribution by clicking the first selection in this particular Google search. So it looks like here's the tables, and they also contain some formulas that we already a little bit familiar with. And first one is a old favorite formula to find sample mean. Remember, X bar. There was another formula that we saw that was dealing with finding a standard deviation. Well, there are other formulas here that I never looked at because we actually using a calculator. And that's why I didn't really show you these formulas before, because there are just too many of them. So people get confused whether you use one formula or the other. So related to the next chapter, we saw the formulas that were dealing with complements. That was the favorite, right? A with a bar. And we also looked at permutations and combinations, but again, I used calculator rather than formulas to find those. And that's why I didn't really look at first pages of this formula tables. But what we need is to take a look at this so-called standard normal distribution, which is table A2. And it turns out this table has 2 pages. One is designed for so-called negative z-scores, and that's not what I have here. So I need to go to the second page, which deals with those positive z-scores. And that's exactly what we're working with in here, because my z, or they call it as a z-score, here is equal to 1.58. So this table is designed in such a way that it gets the area from the left. So from the left side all the way to the number I need is highlighted here in blue. And the way to use the table is to get tens, because the number we have here is 158, has 8 of those tens in it. So from the first row, I need to use 0.08. And then from the first column, I use 1.5. Because if I compose 1.5 with 0.08, I will get exactly 158. So when I follow the row with 1.5 and a column under 1.8, I'm going to see the area, which is 0.9428. That's what the table tells me my area from the left side is. So when I take a look at the actual example in a textbook, you will see that number 9429 is exactly what they found in that table. So the plan is to get used to using these tables. That's pretty much all the section is talking about. So I'm going to go to the section end where the exercises are and do a few exercises. So let me start with problem number 9 here. So I'm in the section 5.2. Exercise number 9 is asking you to find 5.2 the area for z, which is less than negative 0.25. So area or probability is how we will always describe it. So I can picture this normal curve. 0 is someplace in the middle. And then negative 0.25 is somewhere here smaller than 0. So to the left from it. And the area for the values of z that are less than this negative 25, I just highlighted. So I'm gonna click on these tables. Let me share the link to these tables to everyone if you missed how I located it. So you could just click on the link I put in the chat, and it's a good idea to bookmark it. You don't have to download it because this table is always available for free online. So you can just bookmark it. Remember how we did that? This little star here. You can just click on it, so that way you will be able to easily access this table at any time you need it. So first of all, I noticed that I need another positive, but now my z is negative, right? So I need to go back to the previous page. That's where the negative z scores are. And among these, I need to find minus 0.2 or 0.2. So it turns out it's all the way down, and that's the value that I will work with. Also, this 0.25 has a 500ths, right? Or 0.05 for the column. So when I follow the row with negative 0.2 on start, and then go down and follow the column under 0.05, I will get this area. It's 0.4013, you see? It's right where they meet, the row and the column, so they intersect at that particular value. And it's always going to be area from number to the left. I say, Alex, what if you need to find the area from number but to the right? What's going to change? Well, let us select an exercise where we need to find the area on the greater side. That'd be smaller side is on the left, but if you have a greater side, then it's going to be on the right side, right? So let me go to the textbook and look at the exercise number 13, for example. In exercise number 13, they say greater. So when I try to make a picture of this, z will be greater than 233. Okay, greater than 233. So I have to find the probability of that. I always put a p probability because, again, probability is area. We're looking for the areas. So 0 is always in the center. Now 2 and 33 hundredths is going to be now on the right side, on the greater side. So I go the opposite way. So it looks like this is a positive number. So we need to go back to the tables and get positive page. So I'm going to scroll down, right, where the positive z-scores appear. So let us locate 2.33. So it looks like here's the 3 hundredths, right? 0.3 is here. 2.3 will give me the row, and 0.3 will give me the column. So right on the intersection of those two, I'm getting the number 9901, but this is not the answer yet, because this 9901 is always my area from the left, right? What I need is area on the other side from the right. And it turns out that I have to subtract that 9901 from number 1, because what we really care about here is a complement. So we need to see what is not on the left, because we need on the right side. So the left side, the right side. So looks like tables always give us areas on the left side, but I care about the opposite direction, the right side. So as we used formulas for the complement, for the opposites, we subtract from 1, and it looks like the answer is going to look like 0099. You can check it with a calculator if you want. So looks like on the other side, on the right side, I can use the same tables, but then subtract numbers from 1. So interesting, right? How about problem number 21? Look at that. 21 says, in between of two numbers, find the area in exercise 21, which is the same as a probability, right? So we're in between of negative 2.67 on one side, and on the other side, it's going to be 1.28. So this way, I will try to get the area in between of those two numbers. I will actually have to use my tables twice. So as usual, I'm going to make a picture and plot both of these numbers negative to the left from 0, and a positive on the other side to the right. So what they want in terms of the picture is going to be the area in between of these two. It looks somehow like that. So I'm going to go ahead and use the same tables twice. So let's say if I start with 1.28, looks like we're on the positive part of the tables, and I need to get this 800s right here. So 1.2 will be for the row and 0.08 for the column. Please notice I keep doing the same thing. I separate that number of hundreds, and then column with hundreds and row with the tens will give me the area, which is 8, 9, 9, 7. And this is the area from that 128 all the way to the left. So it's more than I need because it also includes a little extra, right? That little extra, which is here, which is actually from negative 267 to the left. So it looks like now I need to find this little area, and I can do it. I just need to go up to the previous tables, right? I need to find negative 2.67. So, yeah. So it looks like I need to take a look at this negative with a 7 of those hundreds. So I'm going to be looking at 0.7, right? 0.7. And then minus 2.6. So where is it? It's here, minus 2.6. So standard process using tables. I hope you're already starting to get used to it. So please double check if I do it correctly. So we got this 0.0038. That's a little tail in here that I don't need, that I need to subtract. So I have to take the big one, that 8,997, and then subtract from it, cut out that tail, because we don't need it in this area in between, and see what's going to come out. It looks like this is going to be a 5, and then 0.89. So I got another area. So we got this in between that happens to be a difference of those two. And I guess it's a nice, intuitive little geometric picture that shows us this, right? So let's try one more, and then maybe you can try one more also using these tables that will be our new favorites. So I'm going back to the exercises, and I guess I'm going to do problem number 12, and then ask you to do number 10. 10 is very similar to 12. So let me do number 12, and then for a little quiz, I'll ask you for exercise above. It's also less than, but now it's going to be negative instead of positive. So pretty much same thing. Let me do 12. So we need to find the area or probability that z is smaller, less than 2.75. Okay, so how we start? We need to separate those hundreds, right? So let us go to the tables, and in these tables, we need to locate 0.05, right? 5 of those little hundreds. If you just logged in, I can again put a link to the tables here in the chat so you can click on it, and page 5 and 6 is what we're working with. So I found this 500s, 0.5, but why is Alex, these are negative z-scores. You have positive, so it's fine. I'm gonna scroll down to the next page, and that's where positive z-scores are, right? So now we're in a better shape. So let me get this 0.5, it's right here, 500s, and then 2.7, positive 2.7 is over here, right? So where do they intersect? Row and the column. It looks like they intersect right here. And that's going to be our answer. It's 0.9970. Because again, if I was to make a picture of this case with 0 in the center, 275 is positive number, which is a little bit bigger than 0. It's on the right side. And what we care about is z to be less. And when z is smaller or to the left, that's exactly what my tables provide us with, area from the left. So that's how tables are designed. So always give you areas from the left. So let's have you try to do for the quiz number 10 as promised, right? So what's 10 is asking you, let me write it, that probability that z is smaller than, let me double check, exercise 10, less than negative 275. Yeah, so it's the same type of a number, but now it's with a minus sign. And since it's with a minus sign, then you need to actually take a look at the previous page, right? I'm going to open the previous page for you so you can find that negative 2.75 among the negative z-scores. Let me actually clean this a little bit so you can better see it. And just tell me what number you see on the intersection of the row and the column for our quiz for today. So please do not hurry. And as usual, put the answer in the chat, right? So I'm going to stop this recording.